Hello everyone, welcome back to our channel. In last video, we have discussed about the class and objects which was there in OOPS, or you can say in object-oriented programming. So in this video, we are going to see in detail about the object assignment. See, there are mainly three kind of object assignment, and today in this particular video, we are going to cover the two kind of object assignment, and the third one we will cover in separate video because that will require a much detailed explanation. So that's why we are going to cover that in our upcoming video. So see, there are mainly three kinds of object assignment was there in System Verilog. First one was object assignment, and the another one was shallow copy, and the third one was deep copy, you can say. So my name is Kittu Patel, and if you have any query, so you can contact me on this number, and also you can send me a mail on this mail ID. Okay, so without further delay, let's start the video. Now, class assignment. See, what is class assignment? Let me explain it with simple analogy. Suppose you have one class. Okay, suppose you have one class. Let's say class name is, let's say my name Kittu. Okay, so you have considered one class. Now take one handle. So we have learned how to take handle of a class. Okay, so just write the class name, and whatever variable name or you can say handle name you want to take, you can consider this. So I have considered now k1, and let's consider the another handle which is k2. Now I am creating object k1. So I have created object by using new. Okay, now I am assigning my k2 equal to k1, or you can say I am assigning all the properties and methods which was there in k1 inside the k2. Okay, so that is nothing but you can say class assignment or object assignment. So see what happened in this case. Suppose you have one class, or you can say you have one class. Inside the class you have multiple properties and method. Let's say you have a, b. Okay, now you have considered two handle. One is k1 and the another one is k2. Now you want to assign all the properties and method which was there in k1 to k2. Okay, so in that case we are using the class assignment. So we will also see the practical example by performing this X on EDA, so it will be more clear to you. So for being now, you can consider whenever you are simply declaring your variable of a class type, memory is not allocated. What they mean to say, whenever we are taking an instance, so suppose kit2 k1, so at that time you have not created any object, or you can say here just you have taken an instance. Here the memory is not allocated. So to instantiate, or you can say to allocate the memory, you have to use new operator. Here an object handle is created which is stored in the variable that you just created. Okay, so see, whenever you have instantiated your class, your variable is set to store the object handle, meaning like your variable as object handle point to where the newly instantiated object is stored in memory. We will see practical also, so don't worry. Now let me give you a diagram so it will be more clear to you. So suppose see, here we have created a class. Okay, so here you can see that we have created one class, whereas we are considering header and data, okay, as in our data properties. So we have taken the two handle of our class. See here, by using class name PCI1 P1 and PCI P2, we have considered two handle. Now we are allocating memory to P1 object, or you can say we are constructing our object P1. Now we have assigned P2 is equal to P1. So here in class assignment, you can say your assignment which was done is like, you can say here your both P2 and P1 are pointing the same memory. So you can say that here you have created only one object. Okay, so see here your P2 and as well as P1 is pointing the same memory. So whenever you make any changes in any of this handle, so it will get reflected in both the handle. Okay, because they are pointing the same memory. We will see, let's perform this in EDA so you will get the better understanding. Okay, so now let's write a code and see the behavior of object assignment. So let me write the code. So let me write a code. Consider one class name, let's say we can write kit2 and then end class. Okay, so we have considered a class and end class. Now let's consider one property. Right now we are considering only one property. let's say int a we have, okay, and one method. So suppose function, here our method is displaying. So function void display, let's say end function, and now we are displaying our a value, okay. So let's say dollar display, and you can say value of a is percentage 0d and a, okay. So see, here we have written one. So see, here we have created one class named kid2, and we have considered two class member. One is property and the another one is subroutine, or you can say method. Now let's create one module. So module, and let's say module name is tb and module, and let's take an instance of a class. So kid2, let's create two instance, kid2 k1, kid2 k2, okay. So we have considered the two instance. Now let's consider one initial begin block. So initial begin end. Now see, let's allocate memory, or you can say let's create one object. So k1 is equal to new. So by doing this way, we have created one object. Now let's assign some value to k. So let's assigning some value to a. So see, by using the handle of k1, we are assigning value to a. So let's say k1 dot a equal to 45. So we have assigned a is equal to 45. Now let's see whether we are getting this or not. So k1 dot display, okay. So we have written k1 dot display. So let's say first of all run this code, and then we will see how object assignment has been done. So see, we have run our code. So here you can see our value of a is 45. Now let's do an object assignment. So let's k2 is equal to k1. So that means we have created only one object, and here our k2 is pointing the same memory location as our k1 is pointing. Okay, so both are pointing the same memory location. Now let's make some changes, or you can say let's modify our k a using k2, okay. So here we are modifying our a using k2. So k2 dot a is equal to 89, let's say we have done. Now let's see the display using k1. So we are displaying using k1. So k1 dot display. So let's see the result, whatever we are getting. Okay, so here you can see that we are getting 89. What does it mean? So see, here it is indicating, here we have made our changes by using the k2 handle, but since it got reflected in k1, because your k1 and k2 is same, pointing the same memory location, okay. So that's why this happened, okay. So I hope it is clear to you. I hope समझ आया होगा सबको. Now let's see the theoretical part. Okay, so again back to the theoretical part. So see, our limitation of object assignment in System Verilog. So see here, your separate copies of the object are not created during the assignment. We have already seen, like whenever you are making changes by using K2 handle, so it will got reflected in your K1 handle also. So you can say that there are no separate copy created for both the handles. So you can say no separate copies has been created, and instead only the handles is copied. As I said, like it is pointing to your same memory location. Your both handles are pointing the same memory location. As a result, any change you are made or any change you have done using one handle, it is immediately get reflected through the other, since they both refer to the underlying instance. Or in simple word, whenever you are doing an object assignment, they both are pointing to the same memory location. Okay, I hope it is clear to you. समझ आया ना सबको? ठीक है, मैं देख नहीं पा रहा हूँ आप लोगों को, पर समझ आ गया होगा आपको, आई होप. So let's see the another one. So here we can see cello copy. Now what is this bala cello copy? It's all the limitation of our normal object assignment. So here in cello copy, different copy of your object has been created. It also has some limitation, and for that we will learn deep copy. But for cello copy, you can keep this in mind. Here for both the instance, you will create some separate copy. So here I have written one definition, so you can read this out. Like your copy allocate memory, and all the variables are copied, such as your integers, strings, instance, handles, and etc. Okay, and your cello copy can also used in randomization and coverage. Now let's see. The below one is limitation, you can say. because your cello copy doesn't create separate copy for your nested class, or you can say nested object. We will see this in next video in detail. What is nested object, what is nested class? We will see the entire things in detail. Just keep patience, okay? And yeah, we will see this. So see, here again I have considered one example, and here you can see we have considered two properties, and here you can see we have considered two instances. So here your each instance is pointing some different memory location. You can see here your each instance is pointing some different memory location. So the result is that if you make changes in any over instance, it will not get reflected in other instance. Okay, so the conclusion is that. Now let's see this through code. So just like we are keeping this code only. I don't want to spend much more time by writing some city code, but you can see this. So see, whenever you are doing a cello copy, so instead of direct assigning this, here you can see let me maximize my screen. So here you can see whenever we are doing a cello copy, so instead of directly assignment, we have to allocate memory to our another handle you can say. Okay, so we have allocated memory to k2 also. Now let's run this code, and you can see the magic. It's magic. So here you can see, like, see, I have done k1.a is equal to 45. That means I have assigned value to a is 45, and then I am displaying k1.display. Okay, that means I am displaying k1.display. So here we are getting 45. That's fine. Now we have done a cello copy, and after that I am changing the value of a through k2 handle is 89. I am making a to 89, but still we are getting 45 whenever I am calling the k1.display. What does it indicate? So here it is indicating that if you are making, or if you have done the cello copy, it will create the separate copy of your instance. Okay, so here your original value will not get affected by changing through its another handle. So this is the overall conclusion for your cello copy. I hope this will clear to you. Thank you.